Fractals are a lot of fun. They have many real-world applications in science, math, and engineering. So let's get right into it. The dictionary definition of a fractal is a curve or geometric figure, each part of which has the same statistical character as a whole. In simpler terms, it's a shape that repeats a certain pattern forever. Let's have an example. We take a square, and let's put a 3x3 grid on it. Now we're going to take out the middle square. Next, we're going to put a 3x3 grid on all of the other squares. We're going to then take out the middle square of all of the other grids. We can then split up the squares into smaller grids, and so on. This is called a Sierpinski carpet. If we take 9 of these and make a cube, we get what's called a Menger sponge. As you can see, this keeps going forever. What happens if we do this with a triangle instead? First, we take out the middle. Then, we take out the middle of the smaller triangles. We can then do that again, and again, and again, and again. As you can see, it will never stop. You can keep zooming in, and it'll always be the same. This is called a Sierpinski triangle. If you take 4 of these and put them together, you get this 3D structure. What happens if you do this, but instead of taking things away, we start adding things on? We're going to start with this upside down triangle, and we're going to add a triangle on each edge. We're going to do this again, remember, on every single edge. We start to get this snowflake structure. As more triangles appear, it gets more and more complex, until eventually the computer can't go to that high of a definition to make out the triangles. This is called a Koch Snowflake. I made all of these 3 different fractals with glue, scissors, and a lot of patience. So first I made the Menger Sponge. Then I made the Sierpinski Triangle. After that I made the Koch Snowflake. This was my Christmas tree made of fractals. It took me 19 hours to build, and it's about 3 feet high.